Hi everyone, in this video I wanted to talk to you about factoring a difference of two squares. So what it means of factoring a difference of two squares is you have a quadratic equation. So remember, a quadratic equation is typically written as ax squared plus bx plus c equals 0. Well, if you have a difference of two squares, you only have two terms there. So it'll be like there's no bx term. You have an ax squared term and a c term. So the formula looks a little different, but the general rule for factoring a difference of squares looks like this. A squared minus b squared equals, and then your factors will look like a minus b times a plus b. So one's minus and one's plus. All right? So what's happening is you're taking the square root of each factor and you just make one plus and one minus because the square root of a squared is a and the square root of b squared is b. So let me give you some tangible examples here. Let's say I said factor x squared minus 36, okay, equals 0. Well, I know that the square root of x squared, well, first let me back up. This would be my a squared term, and then this would be my b squared term. So I know the square root of x squared is simply x. And I know the square root of 36. Ignore the minus, okay? It's called a difference of two squares because there's a subtraction symbol in between these two perfect squares. So I know the square root of 36 is 6. So my answer to x squared minus 36 is going to be x plus 6 times x minus 6 equals 0. All right? That's all there is to it. Okay, so given that x squared minus 36 factored to x plus 6, x minus 6, if you see any perfect squares, you know how to factor that. So here I have this chart that I found on Google, and it has a list of all the perfect squares from 1 to 30. So look, you could have something as simple as what is the factors of x squared minus 1? That's going to be x plus 1, x minus 1. How do I know that? Because 1 squared is 1, so the factors are going to be plus 1 and minus 1. What if I have a bigger number like 17, or 289 I should say? So it says, I give you a problem that says x squared minus 289. Well, we know that the square root of 289 is 17, so I'm going to say x plus 17, x minus 17. And that's really all there is to it, okay? I'll do one more simple example. So factor x squared minus 25. Okay, that's x plus 5, x minus 5. So if you don't have your perfect squares memorized, it might be a little bit harder to recognize. So like, let's work with 12 squared. 12 squared and 144, okay? So you might see a problem that says x squared minus 144 equals 0. All right, and you don't know that 144 is a perfect square. So what you have here is like an x squared plus a 0x minus 144 equals 0. So if you do that, you know, that a times c method, so factors of a times c is just 1 times negative 144. That's factors of negative 144 that add up to 0. So two numbers that multiply to get negative 144 that add up to 0. Well, that tells me they should be the same number. So it should be 12 minus 12. 12 minus 12 is 0. 12 times negative 12 is 144. So I know my final answer is just x plus 12 times x minus 12 equals 0. Okay, so that's, that's how you would do it if you didn't, have your perfect squares memorized or you didn't have that chart handy. Now, I'll just want to do a couple more examples, and that's where you have, like, let's say I give you, 4x squared minus 81y squared. Okay, so you see x squared and y squared, they both have a square, so you can square root that. Can you square root 4 and 81? Yes, you can. What is the square root of 4x squared? Well, the square root of 4 is 2, and the square root of x squared is x. What's the square root of 81y squared? And again, just kind of ignore that negative sign, the minus sign. Don't try and do the square root of negative 81 because you can't do that. You can't take the square root of a negative number. So the square root of 81y squared, square root of 81 is 9, and the square root of y squared is y. So going back to the very beginning, that form of a squared minus b squared equals a minus b times a plus b. All right, so that's going to be 2x, this is the final answer here, 2x minus 9y times 2x plus 9y. All right, see, I just made one binomial minus and the other binomial plus, and that's it. That would be the final answer. Let me do one more. So here I have 64g squared minus 169r squared. Okay, so what's the square root of 64g squared? Square root of 64 is 8, square root of g squared is g. And what's the square root of 169r squared? Square root of 169 is 13. Square root of r squared is r. All right, so my answer then is just 8g minus 13r. Make sure you keep the order the same as the beginning, so that g term came first, the r term came second. So I have 8g minus 13r times 8g plus 13r. And then I can throw on an equals 0. I think I forgot to write that, yeah, on the original, equals 0. There we go. Okay, and, oh, it's kind of all over the place. Let me fix that. That'll wrap up the notes on this video. I just want to point out, it's called a difference of two squares because there's a subtraction sign in between the two perfect squares. So if you were to try and factor something like x squared plus 36 equals 0, that is not a difference of two squares. So your answer would not be x minus 6, x plus 6 because of that plus sign, okay? This one, you can't factor that. There are no factors of 36 that add to 0. 36 is 36 times 1 and 6 times 6. All right, and 9 times 4. None of those add to 0, okay? You would need 6 and negative 6 to add to 0, but 6 times negative 6 equals negative 36 and not positive 36. So if you had something where you see two squares, but there's a plus sign in the middle, the answer would just be does not factor. You would have to try and solve this another way, okay? And so that'll wrap it up for these notes. I hope it helped. Thanks for watching. Bye.